That we have to install in WSL or Windows.
You have to install in WSL because in
Everything.
Windows it does not support.
If Node and other things that support in Windows, that
That you can do. Yes,
whichever are not supported by Windows, only that in WSL.
yes, you can do that. So basically, the backend job, the Celery thing, that will not be supported in Windows. So you will install that in your WSL, and other things you can do it in normal Windows wherever you are doing it.
Node also, no?
Yes, Node also.
Sir, will we have any PYQ sessions like last time?
Yes, that will be the next session.
Okay.
Okay, thank you, sir.
Okay. Any other questions?
So,
Yes, Bhumika.
so what will be the weightage for week 1 to 4, like in quiz 2?
It will be a little bit lower. We have not exactly have this much percent or that, but most of the weightage will be from the week 5 onwards. But the questions will still be there from week 1 to 4.
Okay, so.
Yes, today we will do Celery. Okay, then let's start. Okay, so our topic for today is the server side things, backend jobs, and Celery. Okay, this is visible to everyone, right?
Yes, sir.
Okay. So basically, this is kind of like a higher end topic, advanced level topic that we'll be covering in Mat 2. So this is a kind of like a prerequisite to DevOps, if you have heard of that term. So basically, it is for understanding how servers work internally, how you handle different types of works through the different kinds of servers, right? Because there can be a lot of different types of servers. Essentially, servers are basically someone else's computer that is accessible to a lot of people. So if you host something on a server, how do you actually interact with it? How do you actually use that type of system in order to do certain tasks that require a little bit of more time? That would be the focus for today. So asynchronous backend jobs, that's what I was talking about. It takes a little bit of time and that could happen asynchronously. We have already learned about asynchronous tasks in JavaScript, right? The concept here is similar. What asynchronous task in JavaScript does is your main thread does not get disrupted. But whenever you are working with a long running task, suppose like a fetch request from some other server or some input output operations, that might take a little bit of more time. That happens through asynchronous code. So whenever that finishes, then you run something else. So similar concept is over here, but on the server, on a backend server. Okay, so first let's go ahead with simple request response cycle. We have this looks ugly. Let me change the stroke black. Yes. Okay, so we have a Flask server. Everyone has made a Flask server right now, right? We are currently running it on a localhost. What happens if we run it on a server? Similar thing happens. There is a server. Whenever you're running on a server, it gets the IP address, right? Like something dot not 800. Just a random number, right? It gets the IP address, and you can access this server through this IP address. Is everyone familiar with this concept, IP address? Anyone who is not? Okay. Then you have your client. Let's color that in green. The client interacts with the server through HTTP calls, right? There will be a request, then the server will send back a response. Don't mind my spelling today; it seems to be bad. Okay. So request and response. This is how the normal server works. But is it exactly how servers behave? What if you wanted to scale it to a lot of servers? Suppose there is one server. A server means a computer, right? What do you think? How many requests can a server handle, a computer handle at a point of time? Any guesses? So that depends on kind of workload. Maybe like if someone is watching a YouTube video, some kind of server is serving that, right? How many people can simultaneously watch a video through one computer from the server point of view? Any guesses?
Millions in general they do.
Millions
Means
through just one server.
okay, okay.
It would be a lot less, right?
It
Maybe
depends
like
upon the
Yes,
network
yes.
speed.
It
yes,
depends on
not
network speed.
network speed also, but computer also is doing some kind of work. It has to decode all the data that is there from the database. It has to give it to you and serve it simultaneously. So maybe like a few hundred possibly, or if it's a very good server, 3,000, not more than that. Simultaneously, it can't handle more than that for sure. So what usually is done is there is not just one server. There are multiple different servers, each having their own different IP addresses. Right. Suppose one, two, three, something like that. Okay. So now the problem comes, how will the client know which server to work with? Suppose this has 10 concurrent viewers. This has zero concurrent viewers. And this one is zero. And this one is serving to two viewers. So how will the client know which one to go to? That's a problem, right? We all can acknowledge that's a problem. So in that case, this server, all these servers are hidden behind something called as a reverse proxy. So instead of directly having a server request response, a kind of a reverse proxy is there, or a type of a reverse proxy is also load balancer. Have you heard?
Yes, sir.
Anyone
Load
has heard this
balancer.
term, load balancing?
Yes, sir.
Yes, sir. In DevOps, we learned this that it
Hmm.
states which means which data packet to send where, this
Yes.
kind of thing.
So yes. So this load balancer understands what is the current load of this server, what is the current load of this and this. Everything it knows. So internally, according to the algorithm that it selects, then it redirects it to the server. That one has the lowest one, or whatever. Like basically, whatever is ideal for uh, the load. Right. So this is how the load balancer will work. It will be connected to all the different servers, and then it will go simultaneously. Whichever has a lower load, it will give it to that according to the algorithm. That algorithm we are not concerned about now, but this is how load balancers. Yes. Is
Sure,
there a
you
question?
said that yes, you said that means it will give to whichever server is there, right? So
Yes.
means what that server will do? Does it process the everything and send back the response?
Ideally, yes, but if you're talking about YouTube, we don't know exactly how that works. But
Hmm.
this is how, if a request response cycle is working, it will process all the requests. So whatever, so suppose give the data of this user, then this will send the response back to the load balancer, and then the response from the load balancer goes to the client.
So is data shared between each server because of database? Means like each server is connected to a database, and
Hmm.
that's a common database, let's say. So
Yes,
the whole point of doing this is to reduce the load on the overall
load,
system and increase
correct.
the efficiency.
Yes, correct. So what
Okay.
you're talking about is the data shared between databases. That's a very interesting question.
Hmm.
And in most cases, yes. But in some other cases, there could be only one database,
Hmm.
but there could be multiple different servers that are accessing the database. So the database itself is a different server. When
Okay.
we are talking about actual actual applications, the database itself. So you
Hmm.
would have done Postgres, right?
Hmm. Yes.
Postgres you have done in data DBMS.
Yes.
So
Yes.
in the Postgres itself is a server. It's not a file, right?
Hmm.
So that's how it works. And there could be this can be a very wide topic. There can be different ways to segregate the database servers as well. Because
Okay.
essentially each server wants to have the exact same copy of the data. Otherwise, there could be issues, right? This
Yes.
server
Yes.
has one video, this server does not have that video.
Hmm.
Right? So that's a whole different topic. Very interesting, but that's beyond the scope today.
Okay. No
Okay.
problem, sir. I just wanted to know.
Yes. Okay. Any more questions? Okay. So this is how this the request response cycle works. So as you can see, there are multiple different servers, and sometimes they need to talk to each other as well. So supposing I give you an example, like if I have a payment processor over here, a different server does payment processing, and the color is something different. Payment server. So sometimes these servers need to talk to each other as well. In this case, it does not, and they are the same type of servers. But in certain cases, it also needs to talk to a different kind of server. So that's called a microservice kind of thing. So this only handles payment processing. This only handles data. So the YouTube, if you're taking the example of YouTube, it only handles the data that is being served. So suppose if I want to do some payment on YouTube, there are certain subscriptions and all you can do. So this server has to talk to the payment server as well, and payment server will go give a response back. Similarly, this server also needs to talk to a payment server. Similarly, and you can understand the complexity now, right? If I have just three servers and they need to talk to one payment processor, this payment processor could be also 10 different servers. So now the complexity is rising so much. You can have so many different connections over it. So instead of having single connections from one server to another server, we put in something called, we put a middleman in between. Okay, instead of having all this, we put a middleman that handles all the different tasks. Okay. I put a middleman, and that will handle the communication between servers. Okay, you're understanding the problem here, right? Everyone is. Now, all the servers can be connected to this middleman, and this middleman can handle all the different payment, also the load balancer. It can handle the database that you're talking about. It can handle that also, talking to the database. So this is how servers are actually built in the real world. This is a very simple example, but it can be scaled very much. You can have 10 different payment processes, 10 different databases also running on different servers. So the need of this middleman is very important. Any questions?
This middleman is also a server, is it?
Yes, it's also server that that is specialized for communication between servers. Okay, so anyone knows what this middleman is called?
Broker.
Yes. So this is called the broker. Okay, don't call it the middleman. I just wrote it for easy understanding. This is called the message broker. So the whole purpose of this is to facilitate transfer between the servers. Now I just need to connect this server to the broker, and the broker will handle internally which request this server has to go to. If payment, then go to payment. If there's a database somewhere over here, then it will talk to that. Okay. So this is the work of message broker. Uh, and one of the message brokers that we learn today is Celery. I have not written Celery over here. Oh, I've written Celery. So one of the message brokers that we'll study today is Celery. Is this clear up till this point?
No, sir. What is the job of broker then?
Broker is just like a middleman. They usually are. They just have to transfer data from one server to another, and the way they transfer is different according to the way we have defined it. But the whole purpose is transfer data or transfer request from the server to another server. So
And then
instead
what
of
is the difference between load balancer and broker then? It also
uh,
does the same thing.
it also does the same thing, but it is a specialized server that handles from the client. Any request coming from the client, it will be handled by the load balancer. Then it will go to the Flask server. Only that part is handled by the this load balancer. And load balancer also one more thing is there that it one more functionality for that is it balances the amount of load each server is handling. So that you can call it a special kind of server that handles also the load as well as the data which is shared between the client and the server.
So it connects the client to the server, and broker is like connecting servers to other servers.
Yes, correct. And
Okay.
I should remove this line. This line is not ideal. Okay, this is better. Okay. Any other questions?
Uh, sir, why we are connecting these payment server and class servers?
Because sometimes I need to have, suppose a client is doing some payments, then the client will not directly talk to the payment server.
Okay.
The Flask server that I'm interacting with, will tell the payment server how much money I need to pay, what is the account, and so on. Everything the Flask server that I had interacted with, that will tell the payment server. The client will not directly interact with the payment server.
Okay. Okay.
Okay, it will go through that and then to the payment server. Similar to database, the client will not directly talk to the database. The server will take data. If I want to save something, it will save data to the database. The client will not directly talk to it. Does it make sense?
Yes, sir.
Okay. So now the one way of implementing this message broker is called a task queue that we'll be focusing on today. Okay, it's a task queue. Task queue is a special type of message broker that that takes tasks and so basically it's like a queue. Okay, so any request coming here will go into this queue. If suppose the Flask server sends a request, I'll write R for request. Then when oh no, then it will go into the task queue, and this task queue is like a queue. It should be. The name says it's a queue. So that stores the tasks, and accordingly, whenever the task the since it's a queue, it's a first in first out. So it will do the first, it will request, it will process the first task. Then when this process is done, then it will process the second task, and so on and so on. Okay. Basically, what it does is like a queue. It it will store the task until the queue is ready, and then it will forward the task. So what this allows us to do is having some kind of any idea what this will allow us to do?
Management of data.
Management. What will be the benefit of having a queue like structure rather than immediately forwarding it?
So once the request is complete, then only the other request will process.
hmm That's one benefit. So the main benefit over here is that it can handle a lot of traffic. That means if it's a burst of traffic, handle, let's have burst. If there is a burst of traffic, then what will happen? The task queue will be filled up, but still the queue is there. That means all the requests are still stored. So if there's a lot of burst, it will have store all that, and when it will rate limit according to it. And when uh, the the burst task finishes, then accordingly it will process all the data. Otherwise, the server will be overloaded, right? If there is no task queue like structure, the server could be overloaded, and then it will stop responding, and then all sorts of errors would happen. Since it's like a queue structure, that means it will accordingly, whenever that process finishes, then it will push that into that to the other server. That means it can handle burst traffic. A lot of like suddenly in 10 seconds, 500 or 1,000 people suddenly do some request. Then it will be in a task in the task queue, and then it will simultaneously when each and individual request gets processed, then it will push the newer tasks. So that is the most beneficial thing of a task queue. So it does not allow the server to get overloaded. It can handle burst of traffic. Yes. Question?
Yeah, sir, is this task queue a separate entity or is it like a part of the broker?
It can be a part of broker. It can be also managed individually. So basically, the structure that it follows. So broker can be a lot of different ways. I don't know other. I can't remember the other types of brokers, but task queue is one type of the broker. So the thing that we are studying right now, the Celery system, that has a task queue internally, but it is called a message broker. So it has two task queues actually internally, and then the whole thing system is called the broker, message broker. There are other things as well. Rabbit and MQ, if someone has heard that, that is also a message queue. Any more questions?
You mean to say
So,
Embolic is not a.
so the Celery is a component or a system?
Celery is a full system,
Got
and a
it?
component of that is a task.
Celery is a system, is it?
Yes, you can call it a full server.
How do you really mark it up in a block diagram like this on the
This will be
Celery?
Celery.
The broker is a Celery, yeah?
Yes.
Okay. Say, how do we really invoke that one? Through
Through HTTP calls.
HTTP calls?
Yes. Yes. And
Not the
internally also, Flask
sorry,
can internally
last.
also call that.
Okay.
So we'll
All right.
look at the internal implementation today.
Okay.
Anything else? Anything on the chat? Okay, nothing. Okay, so I hope everyone understood this part, how it works. What are we studying today? Okay,
So
one
the
more important.
task queue,
Yes, task
task
queue.
queue.
Yes, go ahead.
So task queue, you said it fills up, and suppose there is a burst of traffic, so it already filled up, and you said that it will save all the requests, right? But
Yes,
task
correct.
queue is limited, so how it keeps all the requests at that moment?
So that limitation can be, what you can do is have some kind of storage, like a lot of RAM in it. All the
Mhm.
requests are stored in the RAM. So depends on what is the current capacity, but the capacity is usually large enough that it can handle burst.
Okay, and it's first in, first out, right? We will
Correct.
enter it and exit. Okay, okay.
Yes. So any downsides? We talked about the implementation of task queue. Any downside can you figure out with the task queue? Of course, the upside I said it handles burst of traffic. Any downsides?
Time consuming.
Yes. So that means it does not immediately process the data.
Mhm.
We need to know both the benefits as well as the downsides.
Sir,
Yes.
over here also that consumer and the means like that we have to do, or it's just like only one broker.
No, consumer is one that consumes it. Producer is one that produces the task. So if I'm talking about here the Flask server, if the Flask server is sending some request, that will be the producer, and whoever is the consumer. So suppose the payment gateway is the consumer, then it will be the consumer.
Okay. Then why he need broker in between?
That's what this whole thing was about. So broker, because one thing, it can handle a lot of traffic if that needs be. And another thing is, I don't have to manually configure all the different connections from the server to the direct payment. I don't have to configure Flask server to the database directly. I just have to configure the Flask server to the Celery, and everything handles internally.
But again, the Flask server only send the data, whatever.
Yes,
It is a producer, right? So it should
yes.
be, it should know the who is the consumer, and with respect to that only, it will give
Mm,
feed the data.
yes, definitely. It knows who is the consumer of the data, but there is one big thing. So whenever we are talking with servers, right? So you have to know I have to go to the payment gateway. That thing knows. But internally, I have to configure all the different IPs, who can talk to what, and so on. That configuration is very crucial when we're talking about all this. So I don't have to configure that part.
Okay.
Who can talk to what is the different safeguards.
Okay. Then this salary, the broker, where
Hmm.
it is running, means on the server or on the client side?
Uh, no, everything here, this is only the client side.
Okay.
Everything from here to here is the server. There's
Okay.
different types of servers.
Okay. Okay. Got it.
Okay. So today what we'll be looking at is the task queue, not as this particular system, but as a system of doing asynchronous tasks. So asynchronous task could be anything that is a long running task. So suppose everyone has used Instagram or YouTube or something like that. Most of you would have. What if, let's talk with an example of YouTube. So in YouTube, what you have to do first, a user uploads a video, then only others can watch it, right? So that uploading part might take a little bit of time because YouTube videos can be like maybe 100 of megabytes or maybe gigabytes long. So if I'm sending from the client to the server, and the server has to process all that video, it has to create, let's say, what all it has to do. So uploading a video. The upload part is separate. The data transfer part is a separate thing altogether. So let's talk about after the data transfer, after the thing has been uploaded. Any idea what it might need to do? Any what processes? Okay, so
Break
I'll
data
start with
into
one.
chunks and load it individually each part and then stitch it all together.
Mm, that is right in a sense, but the thing is, I was talking about high level things. So
Okay.
all the processing parts. So just for an example, it creates closed captions, CC for videos, right? It creates like different sets of videos, like
Metadata.
1080p, metadata also 1080p video, 720p version of that, 480p version of that, and so on, right? So suppose if you would have seen a video that is very recently, like 1 second or so uploaded, you would only see lower data, this quality videos. Try that out. If
Yes.
like a video
Hmm.
is immediately uploaded, you would only see this kind of only 480p. You would not see the
Yes, yes.
1080p thing. Okay, so all that needs to be processed. It needs to check for play, copyright, and so on. So all these things need to be
Sure,
done.
auto dub is also there nowadays.
What is it?
Auto dub, you can change the language of the
So
video
auto dub.
itself.
Auto dub is there. That's very annoying sometimes. Uh, what I usually do is like watching English videos and then automatically switches to Hindi and then feels weird. Okay. So, and then these are the things it needs to do. So that might take a little bit of long time, right? So that can be done in a asynchronous manner. That means the client does not have to wait for all the things to be uploaded in order to progress, like in order to move forward. It would be very bad experience for the user if I have to wait for, suppose like if it's a long video, 30 minutes, if I have to wait for 30 minutes, it does not take that long, but let's say 10 minutes. Okay. Even 10 minutes would be very annoying. If the client has to wait for 10 minutes on that upload screen itself in order to do all the check, and later on it will say, okay, you are done. It will be very annoying. It would cause a lot of different issues as well. You would not know if the process is being happening or not, and so on. So this thing can be done in an asynchronous manner. So what they usually do is after, so suppose this is the process. You to upload videos there. So instead of having that in the HTTP quick request response cycle, it sends it to a asynchronous server that is specialized for a long running task. So which is our Celery. So this is specialized for running long running tasks. And then when the thing completes, then it will go to the server, and then the client will be notified. So this immediately sends a response back. So it will say request to the server, or maybe let's see, what do you call a task? Task would be a better name. A task to the Celery system, and that can also this will send immediately. It will send a response like a task started. That kind of response this will send back immediately. That means the Flask server will now know that the task has started, and then it will notify the client that task has started. Okay, it will notify the client that task has started or whatever, something has done. And after 10 minutes, when the process itself is completed, then it will say Flask server will notify the client again through something that the task has now been completed. That means now you can watch a YouTube video, or if you even if you have uploaded things on Instagram, that also takes a little bit of time. You get a notification. Not you don't get a notification actually. Actually, I've not used Instagram in a while, so you I might be dated, but it actually did not send any notification. It just uploaded little 2 3 seconds afterwards. Okay, so that means after the time has completed, then the sync server will send the client that it has been now been done. So that time client can do something else as well. Okay, and also it relieves the Flask server also, because the Flask server is not wasting resources on a thing that is long run. It is moving it forward to something else that is specialized for this asynchronous long running task. Hmm. Is anyone has any doubt on this?
Yes, sir. One doubt, if I may ask.
Yes,
Sir, if I didn't understand a few parts of the process, I'm just trying to get my wrap my head around it. So the client first goes to the server to upload a video. So this is a request which is
yes,
sent to the, say, the Flask server 10 or the IP address
yes,
1, and this
okay,
particular video is then okay. It probably goes through the load balancer, but we'll ignore that for
yes,
now.
hmm.
It
That's
goes
okay.
to the Flask server. It gives a request that I want to upload this video of say 500 MB, and that will take about 10 minutes. Right, sir? Is that what you
Correct.
said?
Yes.
Now, sir, I didn't get the connection with the Celery Async uh, box in blue. Yeah, this
Okay,
one.
so this Celery is another server that has asynchronous task. So that means it can quickly send a response back and do the task according to the task queue that we discussed previously, the task queue. And this is a little different implementation. This is a little different implementation from what we are talking about here. Previously, Celery was only moving the request forward, but here the Celery itself is doing all the tasks. So that is a little different. But what is essentially happening? The task is being done, the video processing, and then Celery does all this long running tasks. Okay, all this
So
long running
basically,
tasks. Huh. What?
the Flask server with IP1 is assigning all the tasks to the Celery server.
Yes. Not all the tasks, just this task.
I mean that task, whatever the client has
Yes.
requested it to do, because it's going to
Yes.
take a long time, and that particular Flask server with IP address one will now be free to do other things, process other requests.
Correct. Yes.
Sir, in this, can you explain? Can you also take an example of something from our project, like a Mat2 project, any of the anything like what's happening? Like suppose you have to send an
In that,
email. Yeah, if you can just tell.
exactly. Okay, so maybe not the email. Mm, Actually, in Mat 2, there is not a lot of things. Celery actually has a lot of different things other than this async thing as well. So, if you're talking about Mat 2 project, thing that might take a lot of time would be fetching all the things from the database. Suppose there are like 10,000, 1,000,000 different things in the database, and you want to download all that at one go in a CSV or whatever. That might take a little bit of time to get from the database, do all the tasks, and then send a response back. So in that case, we use Celery to immediately send a response back to the client. And whenever the work completes from the Celery, then we notify the client or directly throw it a download link, something like that. So in your Mat 2 project, downloading things from the so there is a special, what do you say? So suppose download as CSV or something like that. We generally have that as in the project. We generally have that as Celery. We generally throw that task to Celery, and then that does the task. There is also a part of that that is the Celery. This is the Celery worker we are talking about. Then there is another component of Celery that handles the times and stuff. I forgot what it is called,
Sorry, sir. Please repeat. Another part of Celery, which does what?
which handles the timing and all. So suppose you're sending a mail at a specific time.
Okay.
Just a minute. what is it? Celery beat. That is called celery beat. That is also part of the celery system, but that is individual thing on its own that handles the timing. So since the server is running 24/7, it handles at what time what thing has been to do. So that is a separate thing. We won't be talking about that today. I mean, we can talk about that, but we won't be implementing that today.
So
But
this
the
is one
thing,
of the asynchronous backend jobs that you're talking about.
yes, asynchronous backend jobs.
Sir, can we use thread?
Yes, you can use thread, but that will again take the compute of the server, Flask server. We
Okay.
want the Flask server compute to remain not be bogged down with all these tasks.
Okay. So basically, this Flask server is delegating long tasks to salary worker.
Yes, exactly.
Okay.
Any other questions? There should be one question that you guys missed. Anyone asking question? Okay, so
So
one question. Yes, go ahead.
this salary worker and what is the difference between salary worker and salary bid?
Salary
Does
worker is the thing that we talked about, the task queue, then processing all the high compute and not compute, time taking tasks and all. That is the salary worker. Salary beat is a scheduling thing. We
okay,
call it a scheduler.
okay, but it is the one of the thing means salary is the
That is part of salary.
component.
Yes.
Okay,
Yes, celery, if you talk about celery, it's a very huge thing that can do a lot of different things. Celery beat is one component of that.
okay.
Sir, this salary worker is also a server, like where we are
Yes.
keeping. Okay. Okay.
Yes, all of these are servers. So we are
Okay.
talking about a lot of different servers over here, but everything
Mm,
is here a server.
okay.
Okay. So one question that you still missed, this question. I said after 10 minutes, it will notify the client that this task has been completed. How will it notify the client? The HTTP request response has already taken place. How will it respond to the client? How will the client know that Celery system has done the work? Any idea about that?
Sir, did
It
not
will.
understand the question, sir.
What?
So can you explain the question? Like the client is sending it the request to the load balancer to the Flask server. So the
Okay.
salary worker is giving it to the Flask server and automatically through the load balancer want it get back to the client.
No. So what happens here? Request response. Client send a request. Let's take the Mat2 example. Right? Client send a request to the. Let's remove this load balancer altogether right now. Client send a request to the Flask server saying that I want to download all the data from the database. That might take a little bit of time. So now the Flask server sent, okay, Celery, do this for me. Celery immediately sends a response back that, okay, this task has started. Then Flask server will immediately respond back to the client that the task has started. Request, response, over. Now, how will the Celery system notify the client that it has completed? Got my question?
Yeah, you're asking basically how will the client come to know that the job has been completed?
Exactly. There was one answer someone was saying.
A notification from server.
Yeah, but how? Have you gone through? I mean, maybe you might not have gone through week 9 contents. Okay. Any other questions? Any other answers on this? How will it notify? Okay. So there are a few different ways, and some of the ways we'll be learning over here in the course we have also. So we have some certain technologies, not directly HTTP. One thing what we can do, I'm just talking about this part. Celery sending the request to the server, not the request. Celery sending some notification to the client that the task has been completed. Okay, so this is my Flask. This is my client. This happened. This happened. Now it offloaded things to the Celery. Okay, cool. Now when this thing completes, this particular arrow, not it has to go through the Flask server. That because that is the middleman in this case between the client and the job being done. So one way of doing that could be very simple. The Flask will continuously ask the server, is this task done? Is this task done? Is this task done? Can you do that? Is it possible? Very simple.
Yes, it can be done. Continuous requests are sent from the client to the server, whether it's done on the nagging type of things.
Yes, yes. So that is called a polling. So how do we say?
Sir, doesn't polling creates a lot of load on the server, like
Yes,
when you
it
have
does.
multiple? I was exploring webhooks for that purpose.
Yes. Okay. So one way is polling. So that means continuous requests. I'm not sure about the spellings today. Something is messed up in my head. Okay, continuous polling. So as you can see, the downsides are that lot of lot of unnecessary load on the server. This Flask server internally knows about Celery. Okay, so Celery can talk to Flask, and Celery can inform Flask that the task has been done. But the Flask server will keep on track if the task is done or not. So the client keeps on asking if the task done, is the task done or not. So that is polling, and one way of doing that is called a fixed interval polling. That means that like every second you're saying every second slash every 2 second or 1 minute you are asking the server. Okay, understood? Polling, simple enough.
Sir, one more time, please. Sorry, sir.
So polling is basically sending continuous requests to the server, to the Flask server, that is this task done or not? Is this task done? Every second. If it's not done, then it will respond back. The server will respond back that task has not been done. The client will again, at 1 second again, another second it will say again, is this task done? Flask will again say not done. So when the task has been done, then finally the Flask server will send a response back, okay, the task has been done. And then client will stop polling. Okay, got it?
This is one way, right? There are other
Yes,
ways.
this is one way. Other way would be having something called as server sentiment. What this is a special type of request that so what usually happens in HTTP request response is it sends a request, immediately sends a respond back, right? That's what happens in normal HTTP calls. But server sentiment is a special type of event that first makes a connection between the server and the client. And that connection is long lived. Long lived connection. So in this case, what the server can do is continuously sends update to the client. A connection has been made. Suppose this line, if I draw kind of a red line, and this connection is long lived. So as long as someone does not disconnect, it will stay alive. And now this is a one-way connection between the server and the client. So the server can continuously send data to the client.
Means it stays active, and we can do the request and response on that basis
Yes.
on the
Server
same
can
SSE.
on the same this connection. If you're talking about a yes, if you're talking about a connection, then it's the same connection. The client does not have to manually poll every time.
Okay.
Okay. So any downsides on this you can think of?
Is this a two-way connection or
Just a
one way?
one way, server
That
to client.
okay, okay. Server to client. So
Okay.
the client will know when this comes in. Like, how does the client process this information?
Suppose you have in JavaScript you have event listeners, right? You can have an event listener for this particular thing as well. Whenever that event happens, you trigger a function.
Like a watch.
Yes, you can call it like a watch.
Okay.
So you add an event listener to a connection, and then that way you can do that. If you go to, I think I did not take the session on January term. If you go to the September term last year, then I had discussed that in the project session, the server sentiment. Okay, so this is one-way connection from client to server. Sorry, server to client. Any downsides that you can think of?
What if client want to talk to the server, like two-way
The normal
connection?
HTTP call.
Okay.
Okay, so
No,
one
I mean,
is still waste.
how will the server know that the client has heard, or I mean, client has received the message? You said it's a
That
continuously
is
improve.
right. It will not. I'm not sure if it knows or not, but if the connection is active, then that means the client should know.
Oh, that means
But
once
not.
the successful request goes, the client closes the communication, the SSE channel.
It can, but depends on how you implement in JavaScript. Okay. So one downside I can say is still waste resources because anyway it's still a connection, still waste server resource, right? Connection has to be alive. So it's still the connection is still there, still waste. The server has to know this is a connection, you have to send it, but less less resource compared to fixed interval polling because that way a lot of different things happen in HTTP calls. The options, so like TSL handshake and all that happens. So it wastes less resource compared to polling. All right. What can be this good for? Okay, so these can be good for things like when the server has to send kind of like a continuous updates to the client, like
Notifications.
leader, not just one notification, like a lot of continuous updates. Like if you're watching cricket match live on text, not on text, I mean like the updates you're getting live from cricket match. That could be one good resource. Every time some kind of event happens, uh, like a four or a six or a run out, something like that. That event gets automatically, so that event gets sent to the client. Okay, live updates of matches, then some leaderboards, not leaderboards exactly. I'm thinking of other things that it could be good for. Okay, this is the only thing I can think of right now.
Sir,
Yes,
so this SSE channel is established by the Flask server, right?
yes, correct.
So the client has no control over establishing it or anything.
Oh, no, no, no. The first connection has to be made by the client. The client will tell, okay, I want a SSC channel. Flask server will say, okay, I also can make a SSE channel. Then this connection happens. Because otherwise, how will the server interact with the sorry, how will the client interact with the server? That's not possible, right? The first request has to be
But sir,
made
you
from the
said
client
that
to
this
the server.
SSE channel is not used by the client to interact with this class server. That is done by
See,
HTTP protocols.
correct. What I am saying is the data sent from SSE is from the server to the client, but the connection has to be established from the client's end. Why? Because every time, so suppose you're talking about a browser, right? When anyways, if you don't click on that URL or go to that particular URL, click a particular button, unless that event happens, the client cannot send a request to the server. Once you send a request, then this connection is established. Now it's a one-way connection between the server and the client. So from the server to the client.
So it
So
can
both
establish
parties,
these connections,
so
but it
both
has
parties
no
basically know.
privilege to send data to it.
So client will not send data through SSC channel. It will send data through the normal HTTP request response. But the Flask server can have the SSC channel open, and then it can continuously send up the updates. And this can be cancelled by either the client or the server.
So
At the
this
first
live
request,
video
hmm,
streaming is also done via this channels.
no, it can be done, but the SSC channel does not have a lot of bandwidth. That is the issue. So it is not typically done through SSC. It is generally happening like some kind of data that is being transferred, not a very lot of. So videos take a lot of bandwidth. That is not a very ideal case for server sentiments. Okay,
Okay, sir.
it is more like a text updates or some kind of JSON data being sent continuously and so on. That is more of an ideal use case. Okay, then we have another thing called as WebSockets. This is typically a higher bandwidth thing. It's a two-way connection. Now both the server and the client can interact with each other. So that is a good use case for online gaming and all. If you have played chess with chess.com, they typically use WebSockets only and things like that, where you want continuously the data being transferred. The client also has to tell what happened. The server also has to tell the data of the opponent and so on. So this is a two-way channel, and this is the higher bandwidth thing. So it can be used to serve higher bandwidth as well. For video streaming and all, I forget what they typically use. I had one searched, but I can't remember what they generally use for video streaming and all. Okay, are you okay with all these terms now?
Sir, could you explain SSC server sent event once again, please? And
Okay,
also the
so
polling part.
also which part?
Polling part.
Oh, polling part. Polling part is pretty simple. It continuously sends request. Client continuously sends request, and then when the data has come to the Flask, it will notify, okay, the data has come, and then the client will stop the continuous polling. Okay, that is polling. Server sent event. The client first initiates a server sent event. Then the Flask server also says, okay, and this is okay. I can also have a connection. And once the connection is established, now the updates from the server can be directly sent to the client. It's a one-way channel. It is for updates directly coming from the server. Okay, still have doubt or is it okay?
Sir, these
Yes,
web sockets are the APIs or
it's a different connection altogether. It's not HTTP.
No, but it is API for means just
Uh,
like
Oh,
no, it's not API. So when you're talking about HTTP, right? It
okay,
works on some kind of protocol.
okay,
That's the HTTP protocol.
yes,
Okay, so there are different other protocols as well, UDP, TDP, and so on.
yes, yes.
Yes. So WebSockets work on a different protocol altogether.
Okay, which protocol
sir.
they have used?
I think they have used UDP. Let me just check.
Okay, okay. It means there is some frame format that we have to.
It uses HTTP actually.
So let's go into Wikipedia itself.
Sir, one thing I learned
WebSockets,
about WebSocket is that it's
yeah, TCP protocol. Hmm.
it's a uh, like it's a server which is actually active all the time till the since its inception, and it keeps on listening to the events that goes on and on. It's very useful in creating voice agents and all those things that are going
Oh,
crazy today
oh
nowadays.
yes, voice also you can have voice and all, calling and so on. Okay, so
Hmm.
you can use these WebSockets for that. It's a two-way connection, higher sorry, a higher bandwidth one compared to server sent events and other things. Okay, there are a lot of different more types of connections and all, but we will just be discussing this. Okay, clear up till this point?
Sir, then in which case we are using SSE, sir? Because I see that majorly we are leveraging WebSockets because most of our transactions are dealt with two-way connection, right?
Not really. So if you're talking about, so I just gave an example. Like if you're watching match, if you're having a match and you want to update on text, so there are live kind of updates that happen. You only go to that server, it will give you all the updates of the match. So this ball was bowled, this run, how much runs are continuously happening, and so on. That kind of updates can be done through SSC. I think there are a lot of different things that can be done through SSC. It's not brain's not braining. If anyone knows other use cases of SSC, they can elaborate on that.
Sir, those MCP protocols actually uses this servers and events to create connections. They use
Which protocol?
MCP model context protocol, which allows agents and tools to communicate together seamlessly
Okay.
without even defining the tools in AI agents. They use this
Mhm.
as a transport connection layer.
Okay. So there's another use case for you. I hope this much is clear. So
How
the
about
easiest one,
Netflix movie streaming or any movie streaming? That would also be SSE, right, sir?
no. SSC works on HTTP itself, so that the bandwidth of that is very low. Sorry, bandwidth of that, yeah, bandwidth is very low, so you can't stream videos on SSC. I mean, I'm maybe you can. Let's see. Let's Google search it.
In that case,
So Google says no, not used for. Yeah, so WebRTC is the one that you're looking for video streaming. That has a higher bandwidth.
It is used for YouTube as well,
Hmm.
WebRTC.
Okay, so generally
so,
a text-based
only,
communication.
so is it like only for the initial, uh, trigger or initiation of the activity we are leveraging SSE? Is it?
No. So SSC is itself a connection. So the leveraging what you talk about, the initial connection, would be done through HTTP. Even if you're using WebRTC or whatever, it will still be done through HTTP. That will be the connection that generally happens. And once the HTTP is done, now they will exchange connection through WebRTC or WebSockets or whatever you want. So
Okay. So
the
what is long-lived connections are typically we are talking about?
so if you're talking about HTTP connections, they are immediate. You send a request back, you get a response back within 2 seconds or maximum 2 seconds, 1, 2 seconds, milliseconds, and all. You don't have a connection long lived. If it's a long lived connection, your browser itself will say, okay, it is still loading. Right? It will say it's still loading, can't connect, and so on. So that's not a long lived connection. Long lived connection, that means it will be connected for a very long time unless there's some network error or someone initiates a breakdown of the connection. That means it can go up till like 10 minutes, 1 hour, whatever you want, unless someone destroys the connection.
It means the latency is high and it is still trying to fetch details, is it?
No, the latency is not. Latency is the data. Latency means data from one server goes to another thing. So from the Flask to the client, the latency itself does not be affected. The connection itself is long lived. That means the server itself can continuously send data. So basically, what I want to say is, uh, at 0 millisecond, it will send kind of some kind of like Rohit hit six. At 1 minute mark, it will say he got out. At 2 minutes, someone else came to batting. Okay, so all those things can be listened by the client, and it can generate you all the text for that.
Okay.
Got it?
Yeah. Thank you, sir.
So this is through SSE.
Yes. That can be done through other things as well, WebSockets, but that WebSockets is the overkill for that. You don't need two-way connection for that. Okay. I hope this is clear. Different types of ways to interact with the server. Okay, so we were here, and then this one line took us to a whole detour. Okay, so this is the whole thing that we'll be working on today. Let's discuss more on how Celery internally works. This whole thing, how this thing internally works. Okay. So remember, I told you Celery has a task queue inside it. This whole thing is a Celery system. Whenever a request comes, there is one task. That's a task queue over here. Okay. This is called the broker. Uh, this is actually the message broker. Okay, so any task that comes here, a request will come here from Flask. Okay. Request, I would say basically a task would be a better name from here. A task will come here, and then task will be oh, task one. Let me log this here. Okay, a task comes here. Similarly, another task two comes here. Another task three comes here, and so on. This is the message broker, the task queue that we were talking about. So it keeps on track of all the tasks, and internally it has some kind of processors. Every CPU has every system has a processor. That processor are called as the workers over here. It can have multiple workers also. So one CPU thing would have a one worker. CPU system would have two worker and so on. Worker two, worker three. Suppose just for an example, my computer has four cores. So it will have 4 workers in
So core represents the workers, right?
it. Probably. I'm not sure about the core or the thread thing here, but either the core or the thread.
So that earlier thing, that blue part is actually the task queue, right?
Yes, that keeps in the track of all the tasks that are incoming.
Okay.
Okay, so when the task comes, if the worker is free, then it will assign it to a worker. It will assign to a worker, and then when the worker completes, this is the long running thing. Here, all the long running tasks. And then similar to this, we have a backend, results backend. That is also a queue kind of thing. Not a queue really. It's just a database kind of sort of thing. It's called the results backend, where it keeps the process task. So if the process task, if the process task is completed, then it comes over here. Okay. Sometimes you need the process task, sometimes you don't. That's a different thing altogether. But if you need the data, then it comes over here. Similarly, task 2, task 3, and so on. Everything gets assigned a proper worker, and if whichever worker is free, that will be assigned, and the queue behaves, the message broker behaves like the task queue. And accordingly, when it gets completed, it will be sent to the results backend, and so on. Okay, so this is how the Celery worker thing works. It's just the CPU cores that are working on it. The Celery internally assigns what worker or what CPU which a task has been assigned to, and when that task has been completed, the processed result will be stored in the results backend. And at this point, it can notify, it can tell that the task has been completed. So this is the Celery beat thing. Sorry, the Celery worker that we were talking about. There's also something called a Celery beat. So this is a scheduler that's also part of Celery system itself. So if I write over here, then Celery system, everything comes under Celery system. That is a scheduler. So that means it will say at time at 12, maybe 7, do this task. So it already has certain tasks assigned to it, and then it will say at this time, do this task, and now that task will be created in the message broker. So again, T1 will be created somewhere. Okay, and then T1 will be created over here. So Celery beat is just keeps in track of the time that is currently, and according to the time it gives basically the task to the Celery workers. Okay, is this fine for everyone?
Yeah, sir. The
Sir, can you
blue
explain
box.
again?
Okay, so this thing connects here. There is an explainer again, but there was another question. Can you go ahead with that?
Yeah, sir. The blue box is the task queue,
Yes,
and the tasks are stored there. Like uh, even the salary beat scheduler can also dump its task in the task queue,
yes,
and the worker one, worker two, they get assigned as per the order they are maintained in the task queue.
correct. So first in, first out over here.
Right. So, but then the tasks are of different nature. So it is always possible that the task 3 can get finished before task 4, or
Yes,
task 1
definitely.
can get finished later on. And in that
Yes.
same queue, like is it the results backend is also stored in the form of a queue?
No, it's just like a database kind of thing that internally it's in the memory itself. It's on RAM, but it is like a database. You can store the results over here.
Okay, so but basically there is no concept of a queue maintaining over here. Once the task is done, it
No.
gets in the and it gets sent to the server for to be given to the client through polling or SSE or whatever. Is that
Yes,
how
correct.
this is how
Yes,
going to work? Okay, okay.
correct. Okay. So explain again. I won't explain in full detail. Basically, give you the overview. There is a task queue here on where all the tasks gets uh, queued here. Whenever a new task comes, either from a different server or from Celery Beat, it goes over here, and this maintains the task. So if there are multiple tasks, it can keep in track of all the tasks there are, and accordingly, it will assign them to the worker when the worker is free. And when the data has been processed, then it will store it in the results packet. That's the whole thing about Celery.
Sir, one more question. In this, uh, does the worker gets anyway extended to any of the microservices, or how is it, sir?
As a microservice, can you elaborate more on that question?
We were talking about if we can recall the previous screen on
Mhm.
the broker, and then the broker talks to the
Yes.
microservices, right? Payment service and all that, inventory service or whatever.
Hmm. Hmm.
um, how this message broker further connects to um, the API service or the microservice.
Okay. So if we go back to our diagram, so we said this is the broker, right? But I'm saying only this part is the broker. So what I have displayed over here is a general diagram on how things work. But the way we are implementing Celery today, or if we are implementing it on one server, this Celery broker internally handles the task queue as well as the processing also, the processing of the long running task. So this is just one way of how we have implemented the Celery system today. So that means it can be extended based on that only. But right now, what we are doing in this Celery broker itself, we are doing all the processing of the long running task.
Okay, sir.
Okay. So basically, Celery can act as a message broker also. It can also act as a asynchronous processor. Okay. So
So
typically, when we
depending on
have Celery,
the queue that it handles.
hmm, yes. Okay. So one more thing, when we typically have, so when I had drawn this diagram, even when it is just acting as a message broker between different things, you need to add certain kind of different things to the messages also. Maybe have certain logs of where the message is going and so on. So all those things can be done on this Celery broker, and it can be done as part of this processing also.
Okay, sir. Thank you.
Okay. So I hope everyone's clear with this. Okay. So let's implement this approach today. Okay. So for this, you need to have WSL because Celery does not run on Windows. If you have Windows, you need to have WSL. Otherwise, Linux or Mac OS, it's fine. You can implement as is. So I already have WSL, so you can follow along those you have. Okay, so I'll just give you brief on how to install WSL if you don't have that. So if you are on Windows, type in PowerShell, or yeah, PowerShell would be better. Type in PowerShell, open that up, and type this WSL double hyphen install. If you type this, hit enter, the WSL will automatically install. If you have a fairly recent version of Windows, I think Windows 10 and 11 works with this. WSL, again, that's a WSL double hyphen install. So once you are done with this, basically all the steps that I'm using, all the commands that I'm using, that I will mention in a doc, and then that will be in the supplementary contents. I will add that to a supplementary content. So don't need to be worried about that. So WSL, when you have installed it, you will get something like this. When you type in WSL in Windows, you will get something like this. First time you have to set up certain things like passwords and all. That you can do on your own. But after that, once you have set up password, you are inside this. Okay, my WSL is not working. Okay, now it's working. Okay, so now once you are here, you have Ubuntu system running here. So WSL is basically a kind of like a environment to run Linux inside this system, inside a Windows system. Okay, so let me create a folder over here. So the first thing when you come up to this particular screen, you would do update and upgrades. I won't do it right now because it might take a little bit of time. So just for completion's sake, sudo apt update, you do this, and sudo apt upgrade, you you do this. So this will install Python and other things that are required for your system's upgrade. And after you're done with that, we will need to install. Uh, okay, I missed one thing before this. This Celery that we are talking about, this message broker itself is we will be using Redis for this. I mean the underlying Redis for this. Okay. So Redis is the in-memory database, and this is a very fast kind of database. In-memory means it runs on RAM, so typically has less storage, is a little bit of expensive, but is very fast. It's orders of magnitude faster than storage. That is why we use Redis in order to run this task queue. Okay, so we'll be installing Redis for this. This Celery can run on different things as well. It can run on other things. I'm not sure. Um, I mean, RabbitMQ also it can run, but we'll be using Redis. Okay, so first we'll have to install Redis. So you'll have to type sudo apt install Redis server.
Redis
Then
is a database, right?
in-memory databases. Basically a key value primary. So I already have it installed, so I don't need to install it again. By default, when you install it, it will start running. But if it does not start running, you can start running that database using Redis server. Okay, so it says already in use. That means it's already running, so I don't need to run it again. Just to check if Redis is working or not. Okay. So there is one more thing, Redis CLI. That is an optional thing, just to interact with the Redis database. So we might need to install that as well if you want to see what is going on internally in Redis. So apt install again, then Redis CLI.
Excuse me, sir.
Yes.
So Redis server is a message broker, or
Yes, it's a message broker that Celery uses internally.
okay, okay, thank you.
Sir,
Yes.
can we use the means as a developer can use this Redis directly, or it only salary can give means use it?
Hmm. You can use it directly also, and that is used directly also a lot of times.
Okay.
So, have you heard about this term as CDN? You might have heard that CDN.
Yes. Yes.
So, CDNs are very what basically they are like caching kind of service,
Okay.
right? So, whenever a request comes, if that data is already there in the CDN, then it will immediately serve you that.
Okay.
Okay. So, typically, those are implemented in a Redis kind of environment or something similar to that because Redis is in memory. So in memory things are very fast. It's stored in RAM. All the data is stored in RAM. Although, as you can assume, if it's stored in RAM in like certain kind of disruptions like power cut or something would wipe that clean. Right. So that is one problem with that. But typically servers are running 24/7, so that is not an issue. So this is how Redis is used and used a lot of times. It's a very important thing when we are talking about infrastructure and DevOps and all. Redis is used a lot of times.
Okay. Got it.
So,
Wherever you
sir,
need exactly lightning fast things. Yes.
sir, can I ask a quick question? In
Ah,
our
yes.
project folder, there's a backend folder and there's a front end folder. So
Mhm.
this Redis or like WSL has to be installed in the backend folder then?
No, this WSL, Redis server, Redis CLI,
No, I
these
mean,
are being installed. These are being installed on your system, not the folder itself.
no. So what I'm saying that in WSL, I have to open my backend folder, run the virtual environment, and then do the installation, install Redis
Mm,
server or things like that.
are you running your server? Are you running your Flask server on Windows or WSL?
Sir, I was running on Windows, and
Mm,
like now that I find that this has to be done in WSL,
mm.
then I have to open it in what, WSL or the entire thing.
You don't need the Flask can be running on the Windows. It can interact with the database or everything that is there, the Redis and Celery from the WSL.
Oh,
Got it.
so
So this basically makes another server, and your Flask is accessing that server.
the
So you don't
Flask,
need to run the
the
yes.
Flask server with
You
the
don't need
virtual
to do
environment is running in Windows.
yes. You
The
don't need to do any coding on WSL.
the View
That's not
npm the View npm dev is also running in Windows, whereas
yes.
the Celery is running in WSL.
So Celery creates a server, and that server will be interacting with Flask. So
Okay,
you don't need to have anything. Not you don't need to open any folder as such in WSL. You just need to start the server.
from any directory.
Yes, global server.
Okay,
It directly does not matter. The server is there on your system.
okay.
Okay, so Redis CLI, I think that's already installed for me as well. If Redis CLI is not there, okay, not sure. This is just an optional thing. So just to check if Redis is working properly or not, we can have Redis CLI and then ping. It should return me a prompt. If it does that, that means Redis is working properly. I can also see what are the things going on inside Redis using Redis CLI, and then I think it's stats or stat. Okay, so it says every time it says tells me how much memory it is using, how many keys there are, how many clients there are, what are the connections. So this is just what is happening internally in Redis. This just to view that. For your case, if you're working with a project and all, You don't need to do all this. You just have to start the Redis server. Okay, so this is just telling you that Redis is working internally. I'll show you when I actually use Redis in order to create the tasks and all. Then you can see things happening in the database. That's where I'll use this to show you. To close the server, Control C, not the server, this interface. Okay, so for you, you just need to have Redis CLI, Redis server, this thing. That's it. If it's running, then it's fine. That's all you want. Okay, so now Redis is done. Now let's create a Celery thing. Okay, let's create Celery, run the Celery here. Okay, so let's see what folders I have. Okay, I'll create another directory. 25. Okay, I'll do all the coding over here. So first of all, let's start a Flask server. I can do it in Windows as well, but okay, let me do it in Windows also. You can do all your coding in WSL. You can do all your coding in Windows also. Only thing is the servers, the Redis server, the Celery server, they have to be running on WSL. Okay, just for demonstration purpose, I can see if you have a good enough computer, then do all your coding on WSL itself. That's a better thing. But if you have a slightly lower end computer, then it would be better to run the Flask thing on this Windows and then run Celery and Redis here in WSL. Okay, I opened it in a different thing. Okay, so doesn't matter. I'm opening VS Code here in this folder. And first, let's create a simple Flask application, run it, and then we'll install Celery and do all the Celery things that we need to do.
This is in
So,
WSL, right?
but I'll use PowerShell in order to run things. Okay, so here, let's create app.py. So here in this terminal, you can decide what terminal you want. Do you want the bash from WSL or you want the... Okay, I can't get the PowerShell, can I?
Sorry, you have to
Okay, I think only...
configure terminal.
Yes, so let me run from Windows. Okay, now I'm in PowerShell. I hope I am. Okay, it's in bash, but that is from my PowerShell bash. Okay, so typically you would not want to do what I'm doing. Be advised, if you're seeing something like this, you are doing things wrong. If you're doing all your coding in Windows, then your folder should also be in Windows. I don't have it over here. That might cause a little bit of problem. If it does, then we'll shift to WSL. But if it does not, then I can demonstrate. Everyone understood, right? This should not happen. My folder itself is in WSL, but I'm running through Windows. Sorry, in PowerShell. So that should not happen. You should not do that. If you're running from Windows, then have your file system also in Windows. If you're running everything in WSL, then have things in WSL folder itself. Okay, here let's create a simple app. Okay. Mm, I don't think. So let me. I'm even not sure if I have Python here or not. Okay, I do. So great. I'll install Flask. Things I have not installed. Flask, I need to install. I need to install. I actually forgot what I need to install. Let me see. Okay, so if any requirement comes up, then we'll install other things. Okay, let me go to the documentation. That's better. We'll go to the Celery documentation. Okay, so we will do this. So I will use this one, pip install Celery with the Flask bundle. Okay, Celery with the sorry, Redis bundle. Because we'll be using Redis, that's why we will be using this one. Celery Redis. Pip install Flask, then also this one. Celery and then brackets, Redis. So while we are installing, let's create a simple Flask app. Am I audible?
Yes, sir.
Sorry, did you type celery? I think you missed out the Y. Did you in Redis? Celery Redis?
Let me just check. Yes, I did.
But it's still two. Did it?
It's still installed. Okay, so some random package got installed. Okay, I will
Okay.
check that later on. Thanks for informing me. Otherwise, I would have tried to debug and then it would not debug. Okay, so be careful while installing things because it could install some kind of malicious things as well. But also, I installed it in a global. Okay, doesn't matter. Let's go ahead with this Flask import. I'll import Flask. I'll create a app, right? Created this app and then simple run. Okay, just to check if everything is working or not, let's create a simple root. And then let's return hi.
So there's in line number 6, that's app.get.
You can use app.get also. App.route, app.get,
Oh, okay.
app.post also works. With creating a virtual environment. Okay, so while this is happening, let's create things which Celery also requires. So let me name it worker.py And in here, we'll install the things that Flask can use to interact with the Celery system. Again, let's go to documentation. So you follow this background task with Celery. That is what we'll be using. Install Celery, and then this is what we'll be using. Integrate Celery with Flask. So this internal communication will be handled, not handled. This is the function will be used to tell Flask that Celery is present and use Celery in order to do all the tasks that we'll tell the Flask system to do, the Flask server to do.
Sir, is it possible to paste the link in the chat?
Sure. Okay. I don't know why this server is this VNV is taking a lot of time. I know why, because we are here, but I've opened this in PowerShell. But still, should not just take this much time. Okay. So while that is happening, let me just explain what this is doing. Basically, it is a function that says Celery init app that we'll be using to integrate Flask app with the Celery thing. So it expects this app that is the Flask app that we have created, this Flask app that it is created. So we'll pass this app to the function, that function, and then that will return me a Celery instance. Okay. So this is basically running that app in the app context and adding Celery things to it. And finally, at the end, it is returning the Celery app. Half of the things that it is doing, I'm not really sure, but basically it is running Celery. It is running this, creating a Celery using the app context, using the app.name, and then it is returning me that object, the Celery app object, so that I can use it later on in my Flask application, wherever I want to run the long running task.
Sir, what is that app underscore context? That is just the context for the um, what it
Oh, it does
should
not
be
check the
done.
context. It runs that in a context. So what happens is the app could be out of context. The Flask application could be out of context. So what it means that current application context. So if I'm running the application, whatever things that are inside, so all the database connections, all the routes, everything that is in the current context that it is running will it will return this in that context. So basically,
Okay.
if if I don't run this, I just have the app object. It is not running. You can import this app and then it is not running. It will be in a different context. That's why we have app.app context. So you'd be using that a lot of times. Even while interacting with the database, the Flask application needs to be in the app context.
Hmm.
Otherwise, it does not run. Okay, so finally, our virtual environment has been made. And then let me install this. I want Flask. I want Celery with Redis. Okay, that's it. What I want as of now. Okay, Flask is already there. Don't know how.
Have you activated the environment?
Oh, thanks. Thanks for calling that out. How do we actually? I don't really work on Windows. Anyone remembers how to activate on
Go to
Windows?
vnv.venv. No,
Dot
no.
env.
Go to VNV and copy the uh,
Okay,
path
I think
bin.
it's scripts dot
Something
env
like
scripts
this.
slash activities.
What
Ah,
I generally
okay.
do is I just go to that VNV folder bin, and from there I
Hmm.
activate. You can also go there.
Okay, I think this is not working for us. Let's default to the normal territory that we work in, like WSL. So let me do that. Or I can actually paste it in a, better yet, just paste it in a folder, in a Windows folder. I mean, I've not done much over here, but still. So it's new territory for me as well. Running things like having file system in WSL and running through Windows. Okay, so so I'm just pasting the same code over here, and then I'll open it in VS Code. Apologies for wasting your time over here. Uh, just trying out new things. So lesson learned. Don't do what I did. Okay. Now we are in familiar territory. The file system is Windows. We are in PowerShell. Okay. Usually takes a little bit more time to create VNV in Windows. Usually in WSL it's like 2-3 seconds max.
In WSL we have to use Python 3 hyphen MV and v.b.
So you see how much better it was here. Previously, when I was in WSL and used PowerShell, then it took so much time. So again, let's activate pip install Celery with sorry, with Redis, and then Flask also. Did I? I don't think I did. Okay, so this is installing our normal Flask server. This thing is ready.
So rather than using cached data, if we want to start a fresh installing of all the libraries, how to do that?
Rather than doing what?
It says not using cached whatever is the package wheel name.
Oh, okay, okay, okay.
Yeah, I want to not
Hmm.
include that. I just want it a start install, means a fresh installation, like it just fetches the data and does in
There
general.
would be flags for that in pip. Check that. I have not used that anywhere because generally it will check, right? If a new version is available, then it will go to that. If a new version is not available, then it will use the cache data. Okay, so here we are, things installed. So right now, see, my Python is saying Celery is not there. My VS Code is saying Flask is not there. Celery is not there. So in that case, that means once you have used this, you need to point, you need to tell that this is the actual environment that I'm using in VS Code. So click here, go to enter interpreted path, and then whatever you had. So I think this one, but let me manually write it down. So it will be in VNV, then certain scripts or not.
That Python, I think so.
Yeah, I also think so. I'm guessing here because I work on WSL, so not really sure. Okay, so now the squiggly line is gone. That means VS Code now recognizes that I have installed this package. Same should happen with Celery. It also says the Celery is now there. Okay, so this is a squiggly line. Not really matters, but if you want to remove that, you can import from Flask, import the class Flask, but that does not really matter. Okay, finally, the first step. Server running. We are here. Python app.py. Okay, so my server is now running. Let's check. If I go to slash hi, what does it give? It gives me hi. So that means now my basic server is running. App.get, basic server is running. That is fine. Okay, so now let's integrate Celery into it. How do we do that? Okay, so in long running tasks also, there are two different types that you would generally see. One is that you want the response back. Sorry, you want the data back from whatever you are getting. Suppose I am okay, let's take a simple example, not a long running task specifically, but let's take a simple example. I want to add two numbers. I would want the data back. Okay, that's one thing. But if I'm sending emails to the users, I'm sending multiple emails to my users of the application, would I want those emails back to me? I don't think so. I don't need those emails. I just need to know that this data has been sent, everything is done as this. Right.
So
Are you
can you
okay with
repeat
that?
that? Can you repeat that? What we don't
Huh.
want?
So for long running tasks, there are two different kinds of things that you would want. One is the actual data back. So suppose I'm having a plus addition. I'm giving A plus B. I would want that A plus B back after the response, right? But if I'm sending emails to a lot of people, I would not want those emails back to me as a response. I would not, right? That does not mean anything. I would just want that this task has been completed. That's all I want from the database. Sorry, from the server. Is that clear? In one case, you actually want the data from the function that you ran. In another case, you did not want the data from the function that you ran. Instead, you want a success or a failure. That's it. Are you okay with that?
Yes, understood.
Okay. And in certain cases also, if the thing is not very important, like suppose what you are doing here, suppose I'm scraping the web or scraping a site. Do you know what scraping is? Like just taking the site and then parsing all the data and then
Yes, sir.
putting it in my database. Okay. So
Yes.
in that case, if I'm running that every hour, I would also I also don't care if the it says success or failure in the current one, since I'm running it every single hour. So there are certain cases also where you just start the task, but you don't care about when it finishes. That also happens. So these are the different type of things, and each individual cases we would look at. So first, let's look at a task that I just want to start, and I don't care when it finishes. Okay. So just an example for you is the GitHub collaborator request that we are accepting. I don't care when it finishes. I just want to start the task. So just start the task, accepted whenever it does. I just I can see the logs if everything went fine or not, but I don't care when it finishes. I don't want the response back. So that is an example case. So if we have that, so let's have that. First, I need to connect this application to the Celery thing. So for that, we just created this worker.py, right? We need to call this worker.py from the app.py file. So first, let's import. So the file name is worker, right? For worker, I'll import the whatever the function was, Celery init. Okay. After I have created this application, I will say Celery init app and then give it the app instance. And this will return me what? A Celery instance. So I will name it Celery app. You can name it anything you want. Only thing is it has to be on the global scope of this file because we'll be using that to run the Celery system. Okay. Is that okay? Simple.
Yeah,
Just call this
sure.
function. That is all you need to do to instantiate the Celery system.
Sir,
Okay.
can I ask a question here?
Yes, sure.
You just mentioned about globally, but you're running this in the virtual environment, right?
Global in this file, the scope of this file. That's what I meant.
Okay. Right.
Not inside a function. We need direct access to this object. Okay.
Got it.
Okay. So in this case, just do this, and that's it. Now, one more thing is remember when we were talking about where is that diagram? Yes, this message broker and this results backend. This both of these are in Redis. This is also in Redis. Okay. So in that case, I need to tell the Celery system that where is this Redis? Where is the Celery? Where is the Redis running? I have to also tell this because Redis is in itself another server. So to tell that, I have to let's create like a configuration kind of thing. So let's have Celery config. Don't need to do this fancy. You can directly add in the worker also, but just that's what the documentation says to do it. So I give the broker URL. Broker URL is the top part where all the message, the task queue, where all the messages are stored. And in here, you would mention the Redis URL. So currently, my Redis URL is running somewhere. Okay. So if I open WSL, WSL has Redis running inside it. And let me just check what are the commands for seeing that what is running. Redis CLI. Okay, so you can get the server URL using -u. Okay, so let's do that. I have to get some kind of commands also. Okay, these are just the keys.
This is WSL, right?
Yes, this is WSL. Redis will run on WSL. I'm just checking how to check the what URL that Redis is running on.
Sir, can't we just check the ports tab in VS Code?
Let's see. It does not mention that. Okay, so I actually know what server it is running on, but I will Google search how to check that. Redis localhost. So this tells what is the connection that you want. Since this is Redis, you can also have other message brokers also. That will be localhost 6379 and then /0. So you can put anything over here. /0 means so this is the host port and this is the slash whatever you want. And
This is the default port 6379.
yes, and then you have to tell the backend also where to store all the results. So results backend would be again Redis localhost 6379 and then -1. This should be different. Sorry, /1. This should be different than this. In one place, it will store all the task you think. Another thing, it will store all the results. So even fetching the results also will be very fast. Okay, let me Google search how to check what port Redis is running on. Okay, so this command you can use Redis CLI info server. Let's try that out. Okay, yes, we got certain values, and I still don't know the host and port. So TCP port, you can see. We are obviously running on localhost, so it will be the host will be localhost and TCP port 6379. That is what we were looking for. Okay, you have to have the same thing when we are configuring Celery. You have to tell Celery where it is run. Okay, so this configuration is now done.
Sir, how did you check that TCP ports? Huh? Could you go to the place again?
Yes, so
Oh,
Redis
in
CLI info
app.py,
server,
yeah?
not in app.py. This see, right now what we are doing is running the whole application on Windows. My VS Code is now open on Windows. Only my Redis server is now running here in WSL. That's it. Okay, only my
So
Redis
this
server
is
is running.
the Windows PowerShell window, whatever we opened
The
and
black one,
configured.
yes. So just for clarity's sake, let
Okay, okay.
me color it something else. I mean, how do we go to light mode? Preferences, I guess. Okay. So sorry to flashbang you, but here, so this light one, everything is running on Windows. The black one, this one, is WSL. Again, restate. You can do everything in WSL. This is just one way of doing this. If you look at the previous sessions or the last semester sessions, we did everything in WSL. Okay, just to do things differently or to explain that this can be done. I'm just doing that. Okay, since because most of you would have done all your coding on Windows if you're not aware, and if you want to integrate WSL from here, you can do all the sorry. If you want to integrate Celery and Redis, you can just open those server in WSL and still do all the application coding in Windows. All right. Yes. So it says there's some error over here. App.config Celery. So the Celery worker will expect something. So right now it is expecting config key from app.config. So let's have it from object. It's still config from object like we generally do. And then we give it Celery config.py, the name of the file. I hope this works now. Okay, now it's working. Is everyone okay till this point? I hope so. Okay, so now let's create actual tasks that we want to run. Firstly, let me create a long running task that I don't I don't need to see the result for. So let's have that. I'll create all the tasks in tasks.py. Suppose I just need the addition thing. I am audible, right?
Yes, sir.
Okay.
Yes, sir.
So I just need to have some kind of addition kind of thing. So in this task.py, I will define all the tasks. From Celery, I'll import shared task. This is what makes, I hope this is visible. This is a shared task. This is what makes this a Celery task. Otherwise, this is just a function. So all the tasks are in general functions. They have a special they have a special functionality attached to it that you can use to in order to make it asynchronous. So you can have it running through Celery. That's what makes it special. So basically, you can define any task that you want here, any Python task, anything you can, any Python function that you can think of, you can write it over here. And at the top, just add shared task. That will make it a Celery task. And now you can trigger things using Celery. So let's have a simple add, not very original, but just for demonstration. So I will print addition spelling mistakes. Okay. And on top of that, I will say add shared task. This is very important. This is what makes Celery tasks special. And then return anything. Okay. So this is my task. Any function you can write over there. It can be as big as 100, 200,000 lines of code. You can do that. And now this task, I need to trigger it using Flask. So there's a simple thing. Just go into this app, import that function that you want to trigger. So from tasks, I will import add. Okay. So this is a simple function itself, not a very different thing. And with the route, so everything happens in a route, right? Dot get. I'll name it add task. Am I getting any error? And not assignable. Okay, let me write something down. Okay. And now I want to trigger this task. So simply add dot delay. This is the function that allows us to trigger tasks using Celery. Okay, list of str. Let's see why I'm getting any error. I should not be getting error here though. Okay, let me try to run it and then check what is happening. Firstly, I have to run Celery. Right now, remember, we are running Flask. We are running Redis here. I also need to run Celery. Okay. Uh, Clear up till this point? Let me actually run Celery and then. Okay. Celery actually expects the application. Okay, so here what you can do, let me again open PowerShell. So just type in Celery hyphen A. That means what app you want to run. And this app, this is the Celery app that you want to run. App, Celery app, the name of the app. And then I want to run the worker. Remember, there are two different Celery things inside Celery. One is the worker, one is the beat. We want to run the worker. And I will just give a log level as info so that we can see all that is happening. Okay, so one error, I hope you can hear me.
Yes, sir, we can hear you.
Hello, audible, right? Okay, so here I had done one mistake, Celery config, not in Celery config, here in worker. Dot py should not be present, just the name of the config file. Run that again. Okay, I'm getting some OS error. Okay, I should actually be running this not inside here. I should be running it in WSL. Okay, so now opening that in WSL is a pain.
So far we have not run Celery in WSL, right?
Yes,
But you're going to do that now?
yes, I want to do that now, but to go to that file, I have to endure a little bit of pain. So CD, I think it's in. Okay, so I think I can directly open that. There was one way to open WSL, not sure how to. Okay, so manual me. So you can have the Windows file system somewhere over here inside your root folder. It should be inside the mount one, MNT. Okay, CD, then D drive, and then go into the code session and so on. Okay, okay, now I can run this. So basically, you need to move to the where you have created your file, and then let me see Celery is present or not. Celery is not present. Let me add that with celery. Okay, so now everything is done. Then again running Celery through this app dot Celery app. So first type in Celery.
So the command was pip install Celery. That's it.
Yes. -A, then the name of the app, then the name of the instance, the Celery app instance, and then what thing to start worker, and again log level info. Okay, I think this also works. Let me just trial and error Celery, and then in brackets I wrote Redis this line. Okay, now finally it started. Okay, so you can see it has now started. It is connected to Redis, the local host, this one, the one that we had defined. And you can see the different things that are happening inside Celery. So it says the transport is this /0. Results is disabled right now. Not sure why. It also needs to be enabled. Results is the one, the results backend that we had defined here in the Celery config. The results backend we had defined
Is the
that
result,
says
sir? One
yes.
question here. You type this Celery minus a capital A app dot Celery app worker. So what did that command do?
That started the Celery server.
This starts a Celery server, is it?
Yes.
Okay.
Okay. I will fix this. The results is right now disabled. Let's fix this. But what you can see, transport is the message broker. This is the results backend. Concurrent is the workers, number of workers. So basically, they are the number of threads. Right now, my computer has 12 threads. So they have 12 workers in it. And task events, I'm not sure what this does. Okay. So now this is running. And then what we had in app.py, if you go back over here and over here as well, the running server, when we go to this add task, it should trigger this add.delay. That should trigger the Celery server's workers. So it should move that to the task queue, and then the Celery should process, and then result should be stored in the backend. Okay, let's try that out. Localhost 5000 slash add hyphen task. Oh, expects two positional arguments. My fault. Let's add the arguments 10 and 20. Okay, save and restart. Let's go ahead. So you can see it mentions task started. That's what we had returned. So that means this is not, so this is happening in the background, and we are returning whatever we returned from this Flask application. And this particular function itself is sending things to Celery. And how we can test that is check here in my Celery server. This thing is Celery server. Okay, so here you can see everything that happens. Notice this line, task, add task. This is the name of the task, and this is the ID of the task, and this is received. That means that that has been received in the task queue. Now, after that, addition instantiated. This is the one uh, that I printed out in the task. You can see in the tasks, I printed out addition instantiated. That means all the logs here are happening in Celery itself. And now at the end, it says task this succeeded in whatever seconds, and this is the result that is being stored. That means everything happening inside this function now is happening inside Celery. Okay. Any doubts in this? No doubts? Great. So let me just for demonstration purposes
Sir,
add
can
a
you
time
go
delay.
back to the coding window, sir? I have a doubt.
Yes. Which one? The app.py.
Yeah, about the shared task. Yeah,
Okay. Shared task.
app.py
Shared task.
and how we
Okay.
are integrating. Yeah.
Hmm. So basically, there are two steps. One is instantiating that Celery app instance. For that, we borrowed the code from the documentation that was in the worker.py. So this is just a function that is doing some things with our application and then returning us a Celery application. That is the whole thing about this. So what we are doing is importing this in our app.py, importing this init app, Celery init app. First, we imported that Celery init app, and then we called this
Could you
app.
go to app.py? Yeah.
Right now I'm in app.py. Celery
Okay.
init,
Okay,
and
sir.
then ran it with the app. So I gave it the application that I had created in Flask, and it returned me the Celery app instance. Right? And using this app, now my Flask knows how to communicate with Celery. Once I've done this step, it knows how to communicate with Celery. Right? And the communication happens through that shared task, as we said. All the tasks that we are defining, all the tasks that takes a little bit of time in order to complete, that we'll be defining as shared tasks. So I have defined in a different file, but you can do it in the same file as well. So just as an example, I'll put other tasks in the app.py, but let's have it over here itself. So this shared task tells Flask that okay, this can be used to send that to the Flask application. Sorry, to the Celery application, Celery server. And now when I run this function using dot delay, there's the add dot delay function. You saw when I ran this, there was the add dot delay function. So this particular function itself that triggers the Celery job. Got it? And
Add.delay is a
immediately we return.
customized function, is it, sir? Or is it a built-in
Yes.
one?
No, this delay is a
Customize
method that
meaning?
is this delay a method that is acting on that function add.
Yes,
But then we could also run it add 1020 without using delay, right?
exactly. We can do that. But if it's a long running task, then you would not want to do that.
And then delay would delay it by how much time?
No, it does not delay it by a time. It just sends it as a task to the Celery system.
Oh, you mean to say if we just write add 1020, it won't be triggering the salary job.
No.
So delay is mandatory to trigger a salary job.
Yes. Add is just a function. If you do this, add is just a function. I can show that. And remember, previously I had this one task here, right? Okay, one task triggered. Let's go again to the same URL and then try to trigger another task. So again, I refreshed it. Also got the task. This also got the task. But here we did not have any new tasks generated. That means simply doing the add function will not trigger Celery task. Only when you have dot delay, then only you trigger the task.
Okay.
Okay, so this is what sends it to Celery. Dot delay, not directly. Dot delay is what sends it to Celery. Right? Got it?
So to trigger to so is it to trigger a celery task we are invoking the delay function.
Delay function, correct.
And in the
So
task,
what is the 10, 20? What does it mean?
These are the parameters that I had defined in task X and Y.
so
Just
sir,
think of them as normal functions. They are just normal functions. If you want to send it to Celery, add a dot delay to it. Yes, you had a
Is it
question?
like publisher and subscriber 10, 20 or
No, no, no. Don't. This is just a function. Add is a function that takes two parameters, X and Y. So I'm giving those parameters 10 and 20. These are the parameters to the function, the values of X and Y,
okay, okay.
arguments to that
So
function.
what are we trying in that case? What are we trying to achieve here, sir, by calling celery?
We are just demonstrating that you can use this in order to do asynchronous tasks. Suppose, just for example, there is a time delay. So from time, I'll import time. Okay. Let's assume it's a long running task. Mm, Import, let's just import time. Time dot sleep. This is a function, right? Expected position argument. Okay. So for 2 seconds, I want to simulate long run task simulation, or maybe even more, 2 minutes, 10 minutes. What happens now? Now you can see the benefit that when you actually trigger that function, it will take 2 seconds at least in order to return this value. But what we can do for the client, it will say immediately task started. So it will go to this URL and immediately return task started. And this will happen in the background. So that's where asynchronous Celery comes in. Sorry, yes, that's what we are trying to achieve. So things happening in the background using giving that task to Celery and immediately returning some kind of response back that okay, this has been started. Got the use case?
Yes, sir. Thank you.
Okay. Let me demonstrate that as well with sleep. So now if I go into that here, I will refresh it. I immediately get the response back, but this response will come after 2 seconds, or did it? Maybe not. Oh, okay. So one thing we need to do is whenever you change a Celery task, you need to restart the Celery server. Yeah, the Flask server had auto reload in it, right? This does not have a auto reload, so I need to restart the server. Control C to terminate, then restart it. Same command. Okay, so now that should work. Let me change the message again. 2 seconds sleep,
Sir, the
and
two
if I
seconds
refresh it,
leave that we are not able to view, sir.
okay. So just here, it takes 2 seconds in order to complete this task, but the response was happened immediately. So the use cases of this thing would be things that you don't care about when they complete. You just need a response back that this has been started. Okay, so for an example, that I said earlier, like if you are fetching, if you are scraping a website every hour, you just trigger the task. Then whenever it completes, it does. You don't care when it does. Okay, so this you can't read. This one. Hello. What thing you
Yes,
could not read?
I'm not able to view the other screen, sir. I see only uh, the worker.py app.py, not the PowerShell part.
Uh, Sorry. Let's see what is happening. This one you're saying you can't see the bottom side,
Yeah.
but I can see it in the others. Can you see that? I mean, there should not be an issue anywhere because
Yeah, the terminal is visible.
Oh, okay, then I think there is a lag from my side. I'm sorry, sir. Please go on.
okay. So here we have triggered a task and then it completes it. I don't need to know the result of that. But there are certain times you know also need to know the result of something. If you complete the task, you need to know what data is coming back. Suppose you are doing some kind of analysis. That analysis or like a very high computational analysis thing. You have an algorithm for that. You are triggering it, and then at whatever time you want the data back, what is the result of that analysis? That is also one thing that you would need to do, right? So in that case, what you would be doing is again, let's have a app.get. So you will need to have two different URLs for this. One would be to trigger analysis. Okay. I need to create a function for that also. Again, share task is important. And this also takes some parameters also. So you can mention if you don't need the result, you can mention that what was the thing? Just a minute. The results are stored. I mean, if you don't need the result back, you can also mention that. Let me just check. At the top of my head, I forgot. Okay, so there's the ignore results that I was coming to. There are other things as well, but ignore results. Sorry, I accidentally closed the window itself. Okay, so where we were at ignore results. So if you don't want the result of that, in the previous case, as we did not want, we can say ignore.
Can you please share your screen?
Oh, sorry for that. Right. So you can mention in this case, we did not want the results. We didn't care about that. So you can mention ignore results equal to true. That means it will not store the results in the results backend. Right. And this becomes important because Redis is running in memory, and memory, as you know, is expensive. Even higher end computers might not have like more than 16 or 32 gigabytes of memory uh, on RAM. That means if you don't need the results, then set this to ignore results equal to true. That means it will not store it in the backend, won't use that memory, that expensive memory that you have, that can be used in other things that require that. Okay, so another thing that we were coming to, when we actually need to know the result also. So let's do something def get analysis. Yeah. So suppose this is my function, just a
Sir,
dummy.
one doubt I have at shared underscore task, what I understand is a function, is it?
It's called a
Why are we
decorator.
referring it as at, sir, here? Can you explain this line?
It's a decorator. So just learn about decorators. We
Okay.
have used decorators a lot. Even here we have used decorators at app.get. This is also decorated.
Okay.
Basically, this runs before the function.
Okay. Do we need to refer it multiple times? Because for addition function
Yes.
we are referring it. Again for get analysis we are referring it. Can't we not use it in one place?
No. When you're creating routes in application, do you just route? Do you have that app.route just once, or do you have to have it everywhere? Everywhere, right? Or before each function. Same thing here
Yeah.
also. Before each function, you have to add the decorator.
Okay.
Okay. So in this case, let's have some data, some dummy data as parameter, and let's create a hash of that data. I don't know how to create a hash. Okay, you can create the hash using this hash function. So let's create that. And again, we'll simulate a long running task. Let's assume it's a long running task. Okay, and at the end, we'll return the hash of that data, whatever we are sending. And inside that app.py, again, I'll import that function. I think it was get analysis. And as I said, we need to have two different routes in order to get that data. First route would, sorry, first route would be to trigger that function. Another route would be to get the data from the function. We need two different functions. And let me provide it with some kind of data as well.
Sir, is it possible to do app dot route and then do a method post or something like that?
Okay, as you wish. This is what I'm more comfortable with. Methods. Get method is fine for you, right?
Yeah, yeah.
I'll down the time. Let me import date time. Yeah, I'll say imported this, done this at a particular time. Okay, no issues. It's saying templating is not there. Okay, so when I go to this trigger function, I have to also provide a data to it, some kind of string I will provide, and then it will say return task is triggered. But internally, I need to offload that task to the Celery system. So I would say, first I've imported that analysis. I would say this analysis get analysis dot delay, right? Similarly, that we did previously, and then pass in the data that we had. And along with this, also I need to do what? I need to store, I need to pass that data that what is the task ID of this. So every task in Celery has a task ID associated with it. Previously looked at the task ID here. See, this is the task ID, this long string, this one. This is the task ID that is associated with the Celery system, the Celery task. And with this task ID, I can mention if the task is completed or not. I can check if the task is completed or what is the data of that task. So I need to return the task ID to the front end as well, to the client as well, so that later on it can check if that task has been completed or not. Okay, so get analysis, I need to delay that and get the task ID. If I just mention task, that will be the task. And along with this, I will also mention the task ID. Task has a dot ID. So that I can use to send it to the front end. So that using this ID, the front end can now check if that data has now been given completed or not, and the results can be then given back. Okay, so what we are doing is basically triggering this task and then returning that task ID to the front end. Here in this case, I have written a lot of different things, but essentially we are just have to pass in the task ID so that the front end knows what is the actual task ID, and then using that it can retrieve the data. Let me test this out. Okay, it should start with a slash. My server stopped running, so I need to run it again. Now this URL I'll go and see what is there. And then data I will give it 1, 2, 3. Okay, so you can see. Can you see this? Task is triggered at the time, whatever we have here. And this is the task ID. Everyone see this, right? This is important. The task ID is important here. Are you guys there?
Yes.
Okay. So now, since the client now knows about the task ID, they can use this either store it in some kind of local storage or wherever you want. You can store it in a variable also and use this in order to retrieve a task. Let's now create the function to retrieve that task. Again, app.route. Let's name it get data and also accepts a task ID. Using this, I will check if that data is there in the results backend or not. Okay. So to check this, we have another function in Celery. We will use that. That's called async results. So I have to import that first. Async result. This is the function that I'm looking for. Using this function, I can check, using this function and giving it the task ID, I can check if the result is done or not.
So async result does what you said, sir?
I give it the task ID and it returns me if the task is done or not. If the task is done, I can get the data also.
Basically gives you a status update, async result.
Status update. Yes.
It takes an
And
argument that is a task ID and gives you the status of the.
yes. So using this, I can have task status equal to async result. Give it the parameter of the argument of task ID. Okay, that we got from the front end. The front end is giving this task ID. And now, accordingly, if the result is ready, then we will say that result is. We'll just directly give it the result. Otherwise, we'll give it something like not ready. So let's check if the task status dot ready. If this is true, I don't need the brackets over here. If this is ready, then what we will do, we will just give it the result. So let's return like a JSON object. Don't really need to do this. Just but generally you will see JSONify. Okay, and then give it the result. If only if it's ready. So task status. This is the object that this async result is returning, and dot ready is a function that checks if it's ready or not. Gives it true or false. If it's ready, then we'll return the task result or task status dot result. Okay, maybe a 200 code. And if it's not ready, then just we'll return that not ready and give a appropriate code. I don't know, 400 something for, let's have 425. Is this clear for everyone? No doubts. Okay. So while we are at it, let me increase the timer for this. In 2 seconds, I can't copy the task ID and paste it. Let's have 10 seconds. And remember, every time you change the tasks, you have to restart the Celery system. Otherwise, you won't get anything because Celery does not have hot reload. Now you can see there are two tasks now. One is the add, one is the get analysis. So we'll have to have two function calls. One is this, the data one. Okay. And The localhost should be there. Okay, I had already this, and I have another in which I have to get data and paste the task ID there. Okay, so I'm ready. Let's first refresh this. This will trigger this function, gives me a task ID, and using that task ID, I will try to get the data. Let's see. Oh, I don't have a backend. I have the backend disabled previously. Okay, so let me fix that. Remember, we had here backend. There is some problem in the results backend. It says disabled. Let me search why that is, and then we'll get back to this thing. Okay, this is the first time I'm having this particular issue. Maybe something is wrong with the config. Localhost seems the same. Okay, so my fault over here. It should not be result backend. Okay, that's why it was saying the result is disabled because they did not get the proper parameter, proper URL over here. Okay, let me restart it. So now, as you can see, results is there. #1.
So there was an additional S.
Yes, results.
Okay.
Okay, so here also I think I wrote results. Yeah, so it's called actually result backend, not results. Let me correct that. So now everything is working fine. Let's go into the demo again. If I should get this task using the task ID, then I should get the result back, right? Oh, it says not ready. Oh, because that task is not registered in Celery yet. Okay, so let me refresh it, give it another task ID. And now with that task ID, I will fetch if the result is ready or not. Okay, it says not ready. I gave it a 10-second delay. So finally I got the result back. So we are simulating a asynchronous lot of load kind of task that takes 10 seconds to compute the result. And as you can see in the first try, if I try to do it faster, let's see. On the first try, I did not get the result. It says not ready. And in the second try, I got the result. If I go here, it says not ready, and it's ready. Okay. So that's how we can do. What we did here was polling. We were polling each time with a new HTTP call, right? So you can implement that same polling in your front end also. And that is all for the Celery thing that we were working on. Any doubts on this? Basically, most of the things were configurational. Actual coding was not tough. Actual coding was creating this task, which is just a function. Add shared task on top of that. That was imported from Celery and import it in app.py or wherever you want. Doesn't need to be in app.py, wherever you want, and use the dot delay to trigger that in Celery. Dot delay here. If you want the data back, you need to have another route for it, which will take the task ID, whichever format. It can be the post request also. And wherever you want to take, you can take the task ID. And using the task ID, you can check the status of the task. And when it is ready, then you send the status back. Sorry, the result back. If it's not ready, then return not ready. Okay, got it?
Sir,
Yes.
one question. Sir, may I?
Yeah.
Sir,
Yes, sure.
first we got not ready, and then automatically the result
Hmm.
came. So if it's returned already, how come it's going inside that if again like?
Oh, I refreshed the page. I was refreshing the page again and again.
Sir, can you please do it one more time now, just indicating where you're refreshing, sir?
Okay. So I clicked here, got the task ID. Let me try to do it. Okay. I got slow. Let me try to do it again faster. Here got the task ID. Did enter one poll. Okay. When I click refresh now, then it should be past that 10-second window. Now it should give me the result. Refreshed it. Now I got the result.
Okay, okay, got it. Thank you, thank you.
Okay. So what I did here was a polling kind of thing. It was refreshing it until I get the result. Okay. Any other doubts?
Yes, sir. In the session, sir, you asked that what would be a good way to for the server to communicate to the client. How would it do?
Hmm.
Before you started explaining polling, SSE, and the other one.
Oh, yes. For our use cases, polling is fine. But if you want to have that, you can have a SSC connection and then you can send the result back and close the SSC connection after that.
Okay.
All depends on complexity. If you so implementing a server sent event is little bit more complicated than having it like this. This is the simplest thing, right? You are just taking a task if it is ready or not. Implementing a server sent event will be a little bit more involving than this. Okay. Anything else? Okay, I disconnected, so I lost all the messages also. Okay, so if there is no
Sir,
doubt, we'll yeah,
sir,
faster.
I have a doubt for MAD one project. Sir, do I need
Okay.
to add ER diagram in project document or not, sir? Actually, I give all the details about my DB, but do I need to give
How
the
long
ER
is your
diagram also?
this page? The
Two page, full two page.
2 pages, full two
Yeah,
pages. You don't have space to add your
yeah.
diagram. Then link is fine. That is okay. If it was not, then I would have asked you to add the photo, the image also. But that is okay. Not an issue.
Okay, sir, is there any page limit for document?
It's not, but ideally 2 pages is okay. I
Okay,
mean,
sir. One more question is that can I add the .db file and the .git ignore files in my zip folder while submitting the
yes,
project?
yes, you should add that.
Okay, okay,
If,
okay.
yes, but don't make your DB very large. If you have a lot of photos there in your DB, it becomes
No,
very
no,
large.
not large, sir. Only I think near about 50 KB or something like that.
That's perfectly okay.
Okay, 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 sir. Thank you, sir.
Okay. The only thing you have to worry about is the file limit of the uploading. So the 10 MB is the file limit,
Yeah, sir.
the size limit.
Actually, I do the validity check and it's passing actually.
Just upload it then.
Okay, 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 sir. Thank you.
Okay. Anything else? Thank you, everyone. Then very long session. Hope it was good.
Thank you, sir, for the session. It was really good
Thank
session.
you, sir. Thanks, sir.